Thank you all for coming. I'd like to tell you a story. Suppose that by some act, some miraculous act, the hand of fate reaches out and plucks you up and puts you down in a small village in Africa. And there are people outside your table, and some of them are sick. And your job is to figure out what they have and what to do about it. The question is, obviously, that you'll ask, suppose I don't know anything about medicine, and what am I going to have for tools to do this, and all the rest of this kind of thing. So let me tell you what you're going to know about medicine, and that is nothing. Let me tell you what you're going to have for tools. Well, I'm going to try to tell you something about the tools, but what I'm going to tell you is that you have no more than a penny to spend on what you're going to do. So the question is, how do you take disease in some out-of-the-way place and do a diagnosis on something you don't know about for a penny? How do you do that? How am I going to diagnose a case of AIDS, let's say, in a world in which there isn't much there in terms of resources? You really don't have much to work with. And there's an interesting issue that comes up with this kind of medicine, because the circumstances in which one might want to do this in Namibia or India turns out to be not much different from the circumstances in the military, where again the circumstances are grim. There's no electricity, no clean water, people don't necessarily know what they're doing, and even in home health care. If you've ever tried taking care of someone who's sick, you know how little you have to work with under those circumstances. So the problem is a problem that's quite a broad problem. How do you deliver health care at very low cost? This picture here gives you an idea of the real circumstances. And if you look at the laboratory here, this one, that actually looks a little bit like a laboratory. But the gentleman over here in the left-hand picture has set up his particular clinic with a card table in the middle of a market, and he is selling, you have no idea what. But I think if you were wise, you would probably choose not to get sick under those circumstances, because you would not like the outcome very well. So what I'm going to tell you about is this device. And Alex in the back there is going to hand around a couple of baggies and reach in and take one of what's in there. And what those are is the object I'm going to tell you about. It looks like this thing here or some variant on it. And I want to tell you why we're developing this bit of technology, how it works, and what it does. So what is this? First, it's a piece of paper. Second, the colors indicate in this case, two things. It's intended to do a diagnosis for urine for kidney function. And the color on the left-hand side, the red, tells you how much glucose is in urine and is a measure of diabetes. The blue on the right-hand side tells you how much protein is there and is a measure of the kidney function, whether you have kidney disease. And the issue is, how does one make such a thing? What can you do with it? Why is it an interesting technology? And that's the story that I'm going to tell you. And with luck, I think you might believe you might, at the end of the day, even go out and deal with the problem in Namibia. So, why paper, and what is the circumstance that we're using here? And the way usually that we in the developed world think about problems in the developing world, think about cost reduction, is to take the widgets that we have, and then we ask, how can we take cost out of them? And the sort of device that gets used when you go to your hospital and get a test done, the sort of device that you would find there would cost $100,000 to $200,000. It's, fine for our purposes because we don't worry too much about cost. And so the usual idea would be to take that kind of $200,000 box and make it cheaper. And when we thought about how you deal with countries in which the annual health care allocation might be 10 cents, we decided that you'd never get from $200,000 to 10 cents. There's just no way of getting there. So what we did was to start a different way altogether. That is, we asked, what's the cheapest technology that we can think of and how could you possibly use it? And the cheapest technology that we could think of was making comic books. So how do you start with something that's like making comic books and make a diagnostic system? And the idea that we had, very in principle simple idea, is you use the same kind of printers and things of that sort that you would use to make patterns that represent the pictures in a comic book, but instead use those to make a diagnostic device. The question is, can you do it? And of course, you start with paper and you say, that's a pretty obvious idea, and surely somebody's thought about paper before for diagnostics. And of course, the answer is yes. If I look around here, roughly 50% of you are women, and the 50% of you are women have probably used the thing on the left, which is a pregnancy test. And the pregnancy test has, if you notice, two bars. One is T for test and one is C for control. And when you put a sample of urine on the end of this device, the urine wicks its way along a piece of paper exactly as in the device that I'm giving you. And there are also a series of things called dipsticks, which are just drops of paper, pieces of paper you put in a liquid like urine, and it tells you various useful things. But interpreting the colors is sort of complicated, and you really need some medical training to do this. So these are not, in fact, very widely used in the developing world. They're just too expensive and too complicated. So we needed to start by having a technology that would make it easy to make these things. And what we've ended up using, and it works extremely well, is just a printer. It's a little bit different than the printers most of you use for inkjet printing, but it's the same idea. This is called a solid wax printer. And what one does in a solid wax printer is, instead of having a cartridge of liquid ink that you put into your printer, in this case you have a little block of solid wax, and you just slide it into a slot. At the bottom of that there's a piece of heated metal that melts the wax, and then it acts like a normal inkjet printer. But what's useful about it is that this device, where if you look at the device itself over print, right now it costs about $800, which means that in 2 or 3 years you'll be able to buy it on eBay for $50, and another year after that you'll be able to pick it up free in trash heaps. So it's going to be effectively a free technology. So what we do is to design our system, easy to do on a computer. You print it out on pieces of paper, and we've used filter paper, we've used toilet paper, we've used newsprint, we've used almost everything. It all works pretty much the same way. And you print it out, the wax goes onto the surface, you heat it for a moment, it seeps through the paper and makes barriers. If you put a drop of serum or urine here, it wicks its way up here, but these lines here, which are the lines put down by the wax printer, channel it into the test zones. I mean, it's an idea that's as simple as we can make it. There's another really critical reason for working with paper. And that is that, of course, in the developing world, you don't have any needles and vacutainers and things of that sort, the kind of thing that you'd count on having in a hospital. But even if you did, and even if you could pay for it, there's a problem. How do you get rid of contaminated stuff? And the nice thing about paper is that all you have to do when you're finished is you put it on a fire, then it burns. So sterilization is complete and simple and something that you can do everywhere. Here's an example of a test system. It's very much like some of the ones that you have. That page can be produced in about, well, you produce about 1 every 2 seconds. So you can really crank them out. And the cost of the page is about 5 cents, so the device costs about 1/10 cent a device without the biology and the chemistry added. So it's very, very inexpensive.